Yes, yes, we can see.
Okay, so this is just an introduction. This is the machine that I'm showing you is the DGX machine with 4 GPUs, and each has V100 GPUs. Each GPU having 32 GB memory. So how do we know that on which GPU I am working? What is the configuration of GPU? That's how I can check it. So I have logged into this. This is my office GPU. This is GPU server. So I have logged into using my SSH. So in this machine, if I do NVDIA SMI command, so if on any GPU, if you do NVDIA SMI, you will get the details. So you know that the CUDA version, here the CUDA version 10.1, and the driver version, you'll know the detail. And you know the GPU, 4 GPUs are there, Tesla V100 GPUs. And you know the what is the memory, 32 GB memory, 32 GB memory. And you know that how much memory is being used. And this percentage, so this shows that how much GPU utilization is there. So in the first session, I was talking about the GPU utilization. So this GPU utilization ideally should be very good. So it means that your hardware is getting utilized, correct? So, okay, now I'll just talk about the, okay. Now let me talk about deep stream. So, so can you see the screen? Welcome to Deep Stream Intelligent Video. Okay. So what is deep stream? Okay, so I'll just talk about it. Initially in okay, so see in any any computer vision application. So model building is one part. Right? So you let's say you build object detection model, or you build any people detection model, or any ResNet model, right? Anything you build, that is just one part. But if you think of, let's say you just take just take one practical example. Let's say you at the airport, you want to deploy one model which is face recognition model. Right? So face recognition model has to have pipeline, something like this. First should be face detection model, then there'll be face recognition model. Correct? So, and then after that face recognition, what you want to do is that based on that face recognition, you want to query some data set, a database, and then based on that database, you want to do some processing. Let's say some element which is threat to security or something like that. And if you have some database registered, right? And if some that person comes at the airport, and you recognize that face and you query in that database, and if you find that okay, same database is matching, then some alarm can some automatic alarm can go off, and then it can alert the security agencies, right? So this pipeline you can think of. So in that kind of scenario, so think of whole pipeline, how it will look like. So first thing will be the image, the video capture. It always will be video capture. There'll be multiple cameras installed, and that will be capturing videos, and that videos has to be passed to, that video has to be usually those videos will be RTSP protocol, or some if it's on the web, so mostly it will be on the web based, so it will be RTSP protocol. So those video will be streamed to a server. That server will do all encoding or decoding and all the processing it will do, and then your ML, deep learning algorithm, inferencing will apply on that. And then after inferencing, based on that, you want to take some decision. So you know that the deep learning inference is just a small part of it. If you think of some pipeline, if you think of some real life application, so it's just a one part of it. It's not full pipeline. So we need some application, some pipeline, which actually makes it possible. So if you so deep stream pipeline is helpful there. So it gives you one framework where you can put your trained model easily. You can put your trained model easily in this pipeline, and it has everything enabled. It gives you the framework for video decoding. It gives you the framework for it gives you the framework for batching, uh, and also encoding as well, and also for how you want to process your videos. Let's say on the videos you want to put some bounding boxes, right, on the people faces or detection, and you want to send that data over the stream. So you can again send those videos over RTSP protocol, or you can, or you can just generate some insights from those videos. So you can imagine that it's a one pipeline. So we need some framework or some application framework which enables us to do that. So deep stream is applicable there. So as you can, so in any application pipeline, so there'll be some file source, right? So this deep stream is based on deep stream pipeline is open source and from NVIDIA, and it is based on GStreamer. GStreamer was also open source, but that is C++, and it has Python binding also. That is based on, it's also open source. So DeepStream actually extends that open source project, and it adds some accelerator. So for example, let's say video decoding or inferencing, that can be parallelized and that can be executed on hardware, right? So that plugins NVIDIA provides in that. So you can see that this GST NV decoder, GST NV, for these are the specialized plugin that NVIDIA provides. These are the hardware, these were the hardware accelerated plugins, right? So on the top of GStreamer, this deep stream pipeline has been written. So I'll just explain you what are these pipelines. Right? So originally this pipeline, this code has been written in C++, and this plugin has been written in C++, and it has Python binding as well. So what it means that you can do your coding in C++ also, and you can do your coding in Python also. So in any language, if you are comfortable, you are fine. So let's see the one example how it goes. So file source. So file source can be, you want to process one video file, either it can be from your USB camera, or it can be file which is saved in your PC on your hard disk or disk, or it can be over the streaming RTSP protocol. Once you have the file source, then this file has to go to decoding, right? Because usually videos will be in the encoded format. Either it's H2 compression will be there, H264 or MP4 format. So that has to be first decoded before we can process it. So this decoding, NV decoding, this plugin will decode it. These are the this decoding is also very fast on the GPUs are utilized to make it very fast. So once this decoding has been done, then so this video has been converted into NV12 format, right? On that NV12 format, we can do this detection. So whatever this classification or detection or segmentation algorithm that we have, we can use it here. So this is just a plugin. Whatever deep learning trained model we have, this is just a plugin, and I'll tell you how we can use it. So in this plugin, we just provide the model path, which model to use, and it will just do the inferencing. So once we have done the inferencing, so all the bounding boxes results, all the whatever results will be there. It will be just one metadata, and it will be appended into video stream. So let's say at this particular point, when the video was starting, at that point, you have the video, you have the frames, and the video data, basically. You have the video essentially collection of frames. And the moment it passes through NV Infer plugin, it means that now classification or detection has happened. So whatever detection or whatever output is generated from that algorithm, deep learning algorithm, is now appended as a part of as a metadata in that. So now is added back as a metadata. So now this metadata passes, and now you can convert that into that is again converted into RGB image, RGB video format. And then you can draw bounding boxes, and then you can write one probe function. This probe function, you can basically want to know that at this particular, if you want to know, you want to do some analytics, you can do through some probe function, callback function that I'll explain. And then you can send your processed video to the relevant pipeline. So multiple places you can send it. And in this thing is that you can process hundreds of cameras at a one time. So if you have a very good parallelization, let's say if you're using 800 GPUs, very high quality GPUs, right? So you can hundreds of cameras, you can send images. Let's say on the airport, you have hundreds of cameras, right? And all those hundreds of cameras will send you feed at one time. And those feeds will go to this NV decoder plugin and NV badging plugin, and then this will go to the GPU, and this all inferencing will happen, and all this thing can be parallelized, and it will happen. Right? So this is at very briefly and very high level, I have given you this overview of this pipeline and how it looks like pipeline. So internally, if we look at just one plugin, right? So if let's look at one plugin. So all this one plugin is, so let's say NVInfer plugin. So NVInfer plugin is something which where our deep learning algorithm will be used. So in NVInfer plugin, so what is the input? Our input will be video data. Output will be also the same video data, but some modified metadata. And how those metadata will become? That will come from the classification or whatever deep learning algorithm segmentation or detection we have used. So that will come from. So this is the concept of this plugin. So this pipeline is composed of individual plugins, and we can attach these individual plugins to make one pipeline. Okay, so these are the, I'll tell you. So let's now, so now we'll see one example now. Okay, so I will start one example how to make pipeline and how to show you. Yeah. So can you see this screen, introduction to multi-DNN pipeline? Hello? Can someone respond? Can you see this screen? Okay. 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 Thank you so much. Thank you. Okay. So yeah. So so I'll just give you one example how to make a pipeline and how to we can how can we can make a classifier, right? So in this one we have one file source. We can add a okay. Okay, so let's look at this one example. Okay, maybe I should take this simple example that will be. Okay, before that, we'll go to this plugin. Yeah, let's go to first workflow. Then I'll go to example. So whatever I explained you, we can just go through this image again. So we can see that the source of input can be your different way of collecting data, directly from your USB camera or RTSP camera, you can get the video. Then the decoding can happen, decoding will happen. Then you do all this pre-processing and this inferencing, classification, detection, segmentation will happen. And then we do encoding because still the images are in the raw format. So we need to encode the images. Not images, videos. We need to encode the videos, and then we can visualize it. We can gather the insights, or we can send those videos. Okay, so now let's look at how this parallelization can happen here. So let's say another example. So now let's say you are sending the three incoming video streams. 3 videos are coming, one from camera, one from disk, and one from network, right? Multi-stream input. So all 3 videos are coming at a time. Now this batching can happen. All these, so from these 3 videos, packets of videos will be made, and this parallel processing of videos can be done on the GPUs. So all this pre-processing, decoding, as well as inferencing can be parallelly can be done. So that's, we call it batch inferencing. So that's why high throughput, when we say these many frames per second, is possible, because now so many videos, so many streams we are able to handle at one time. Right? So that's we call the batched inference. Right? So that's how we see the performance. So let's say one example, if we see that 2 GPUs, if you see the performance, so number of streams throughput, if you see the performance, so what is the performance? So Tesla P4 versus T4. So number of streams per second, how much streams you can handle? So 50. If you this is just a comparison, right? So for two different resolution, how much streams you can handle. So okay, so these are just I'm handling the different, talking about different applications. And so now let's look at the code part. So before code, yeah. So all these plugins that so I'm just talking here since I have to cover in 1 hour. So I'll go a bit fast, but I would request that you can go and just try out this. This is also available as a Docker container in our NGC container. You can try it out. Okay, so yeah, you can try it out. So now let's look at the code part. So for this example, what I am doing is that I'm just one file source. So in this case, file source is nothing but file source. File source is available here on my in this server. So you can see that sample 720 S264. My video is already present here on this path, and output I'm storing it here, correct? And which classes I want to detect? 4 classes. Okay, so I want to decide, okay, vehicle, cycle, person, road sign. So 4 classes I want to detect. So here, that's how I can define, okay, these 4 classes I want to detect. Okay, and so this is my basically NV-Infer plugin, right? Similarly, after that, so NV decoder I mentioned. So NV tracker also is there. So NV tracker plugin is that, so once, let's say, once you detected some object, let's say car you detected, correct? So same car you don't want to detect again, because that object already you have detected. So you need some kind of tracker so that you don't redo the same thing. So the tracker's purpose is that. So that's why after primary detector, so you can actually add multiple classifier here. So after GST, after this infer, you can add this tracker element, and then you can add multiple classifier here. So you can see that GST infer, S1 classifier, S2 classifier, S3 classifier, right? So what it means that I have added this car detector. After that, I have added this classifier, this tracker, and then I've added another secondary classifier, that is car color, this car make and car type, right? So it means that in just a pipeline, I can simply add this, add these models. In this pipeline, I can just simply add these models, and I can build this pipeline, right? So this is just an example. So I'll show you in the code how it is done. So this is just the way I'm just defining this class label. Okay, for my primary classifier, what are the classes I want to detect? For this example, vehicle, cycle, person, and road sign, right? These 4 classes I want to detect. And here I'm using pre-trained model, right? Pre-trained model I'm using. I'm not training any model. Model has already been trained previously. Okay, so this is my input video and output video. Okay. So as I mentioned, that the most important thing here is that making a plugin, so making an element. So all these things here is that in decoder, in NV-Infer, tracker, everything is an element, right? So we need a function which can actually we can actually make an element. So this is the function which makes an element. This is the factory method. So we can create an element, right? So this is just a function that we'll be calling again and again while creating the element, right? And this is just a way to initialize the pipeline, right? So we'll just, because this is just pipeline, so we are initializing it. So G object is nothing but, since this is, I already mentioned that this is based on G streamer. So this is just, I'm importing the relevant libraries, and I'm running inside the deep stream container. I'm running inside the deep stream container. So so from NGC and a container, which I mentioned that if you it's very easy to download. I'll tell you once I show the code, I'll tell you how to go and do it on NGC container, right? So you can wait a minute. I'll just show you right away. Then that will be easy. Can you see my this NGC container ring, right? So here, let's say I'll say you deep stream. So in this NGC container, it's just a free, so you can make an account. So let's go to the container, okay, and deep stream. What I'm talking, so deep stream, see, this is the deep stream container which actually I'm running, right? So this deep stream container, you can pull tag. You can just run this sort of command, this Docker run. What the same thing I have done. You once you run it, then you will be inside that container. And then the way I have run this Jupyter Lab, you can run and do it. I'll share the code location. So after that, you can try it out. Okay. Right. So you can see this. So the morning I was mentioning, this is the NGC page. So in this container, see deep stream, you can see here. Similarly, I was mentioning about Tau in the morning, right? So Tau toolkit, right? Tau toolkit. You can Tau toolkit. So pre-built model. So everything is here. All these models, you can explore this NGC. All these models you can download. All the details, what I was mentioning, PeopleNet, all these details you can go and you can find it, even download the model, right? So every details are available here. So, and all these are free. So you can go and check it out. Okay. Okay, now let's go back at the code now. Okay, so sharing. Okay, so my code visible, right? Okay. So now let's see. So in this one, so this is just I'm importing these. I'm inside. See, keep in mind, I'm inside this container. So that's why I'm running this container. I'll just show you. I'm share another screen then. Okay. Can you? Yeah. So this is the machine where I am. See, that's how I launched this container. You can see here. Yeah, so before this call started, I just see Docker run. That's how I launched this container. I deep stream. I just made it different name. Since I modified this container for this talk, so that's why. So that's how I launched this Docker run container, and I'm the deep stream 5.0, right? So this is I'm inside this container. So once I this Docker run, I'm inside the container, and inside container I'm launched. So once I launched this Jupyter Lab, so it has opened on this server. So that's how I came to I have opened to on this Jupyter Lab, right? Okay. Because currently do I have to register? Okay. You need to create an account. You need to create an account. Yogesh is asking, do we have to register for accessing the, but because no, you need to you need to actually make an account, and then it will ask you access key, and then you can download the content. Okay. But the thing is that most of this thing requires to run on GPU. So that's one thing that you need to be aware of, right? CUDA should be there. Okay. So NGC, but some of the, let's say, Triton Inference Server can run on your CPU also. So you try it. I mean, some of the containers will run on your CPU also. So just try it on NGC. You go and check. So whichever is working, you can try it, and you can make your account there and just try it out. So if you on your machine, if you have a GPU, then you can on the top of container, you need to on the top of Docker, you need to install NVDIA Docker as well. I'll just tell you NVDIA Docker as well. If you don't want to run on the GPU, then it's not required, right? So you can just Docker is enough. So NVIDIA Docker is required because because Docker has to interact with GPU, so that's why this is the additional layer over the Docker. But if you just want to run on the CPU, then NVIDIA Docker is not required. So just explore NGC. You can find which one you can run it. Okay. Okay. So now on this pipeline, you can see that this part we have discussed already, that's make element. So now I'm just initializing this pipeline. So let's run it as well. So I'm just this portion I have run. This is just a function, it will not do anything. I'll just call later point of time. So this is just G object is nothing but the G streamer pipeline initialization I'm doing. This is just a syntax that you need to follow, no need to change. I mean, most these things will be constant, it won't change. It's just it doesn't require, main change will come here, creating element, right? So now let's create the element. So first thing we need to create the source, right? So we need to first source, and what is the source? File source, because my file is present here. Where is, I'll show you my file. Where is my file present here? This one. It's a deep stream 5 sample stream. So let's say deep stream 5 sample stream. See, this file is present here, right? So this file is present here. So it means that my file type here is file source. But if let's say it has been RTSP protocol or USB or some other, then accordingly I need to check. I have to make it different kind of file source, right? So it will be then RTSP file source will be different here. Similarly, after the source, I need to make a parser because this is S264. So I need to parse this format as S264 parser. Once I have done this parsing, I need to have a decoder because you need to decode the video also to make it run on so that we can run inferencing. So make it NV12 format. So this decoder, we need this decoder element so that decoding can happen. After this decoding, we need a streamux element. So this streamux element is nothing but, because I mentioned that let's say you are taking from 10 cameras, right? So all this, so how to create the batched input. So let's say 10 videos are coming at a time. So how to create the batching? So at that time, this streamux will allow you to do that. So form batches. Similarly, this primary classifier, you can make this PGI is nothing but a primary classifier. So the first classifier that you want to put. Then tracker, after first classification, the first classification is a car. The first classification is which is the right car type, vehicle detection. Second is the finding car color. So secondary classifier. Secondary classifier. So similarly, I'm adding chain of classifier here, right? Chain of classifier here. So all the, so how it is, how easy it is to write, you can imagine, right? I'm just for this pipeline, this classifier is nothing but just one plugin. This plugin type is NVInfer plugin, that's all, right? All this classifier I have added in this pipeline. In this 5 line is all added, correct? Once I have added this classifier, now I need to convert, because now all this classification and all this detection is happening on the raw video format. Now I convert it to RGB video format so that we can draw bounding boxes and we can see it. Okay, what are the NVInfer advantages compared to other resources? So NVInfer advantage is that, see, NVInfer is highly optimized to run on the GPUs, right? So NVInfer, see, if you run on NVInfer, so NVInfer plugin, correct? So NVInfer plugin is a layer of C++. Though we are writing code in Python, but it's calling C++ function, and it's taking your classifier and video stream and distributing it on your GPUs. Right? So whatever processing is happening is really, really fast. Right? If you just take this model and just simply call PyTorch based plugin and all it, then your inferencing will be really slow. But NVInfer plugin, what it is doing is that it's taking your video input and it's just parallelizing it, right? Because it's calling many CUDA, underlying CUDA layers to parallelize it. So that is the powerful feature of this, because it's splitting your, it's sending the job to the optimizing it. So that is the advantage. So it's just a plugin which actually optimally calls your classifier, your deep learning algorithms, right? So you get the very high performance, a very fast real-time performance you get. And it's also very easy to do that, because you just need to define it, that, okay, which classifier I want to use. I'll tell you that how to provide the path and all. Okay, so once you have this raw data you have processed, then you can actually look at this you need to convert this into RGB format, because that's how we can visualize. And once we convert it into video, into this NVDIA conv, it converts into RGB format. Similarly, this NVOSD, this is another. So I understand that you won't be able to remember all these things, but it's fine. You just get the feel of this pipeline so that you can try it out, and you know that, okay, at very high level, that you understand, okay, these things are possible. That's the purpose. You know that, okay, these things can be easily done. That is the whole purpose of doing it, because it's not possible to remember it. But just be aware that, okay, these things is possible. It can be done very easily. Right? So NVOSD is nothing but you have to draw bonding boxes. So it just provides interface for that. So these are the different elements. So once I run this command, so see, it created all these elements. So sync, container, code parser, encoder. So because after this thing, I need to encode also, because I have to send the video, I need to compress it. So whichever format I want to save. So here I'm saving my video into MP4 format, right? So I need to create encoder also. So see, so I have created encoder. So this encoder MP4 encoder I have created, because I want to save my image into video into MP4 format. Right? So all the elements I have created. Right now, one important thing is that, so the thing is that how we need to there are lots of config file. That is important, right? We need to see the config files. That so we need to set the property that, okay, which, now the question will come that, okay, which model to use? How do you tell this pipeline that, okay, you use this model, right? You use this model, and how to set the deep learning model property? I'll tell you how to do that. So that's how we do in this property. So as I mentioned that here the deep learning model is nothing but just a part of this NVInfer plugin, right? And NVInfer plugin is not we defined NVInfer plugin, two types of NVInfer plugin. So NVInfer is a class. So we defined 4 objects basically. One was primary classifier, and 3 object was a secondary classifier, right? So these all 4 are PGIE, SGIE 1, 2, 3 are nothing but the NVInfer. So it will all have property. So all these property are related to classifier. So we'll open this file and see what these properties are, right? So let's open this file. What is this config file? So let's open this, and we can just in this property file, we'll see which models and all that is using. So how we can source code. Okay. So yeah, so this is the path: source code N2 DS test2. So let's say DS test2 PGIE config text. So how does a config file look like, right? So in this one, you can see that the primary classifier is referring to this config file. So it means that for NVInfer primary classifier, I can set this property through this config file. So let's look at this config file. So these are just comments. Okay. So what all things you can provide through this? So these are just comments. You can have a look over it. So I'll just share the code. Okay, so in this one, see, first thing, important thing is that you can provide on which GPU to run this code. GPU ID is equal to 0. Even you can decide which GPU to run this code. So that level of control it provides you. Right? So that easy it is. So I was telling you that on this machine, 4 GPUs are there. NVIDIA SMI did, and you saw 4 GPUs are there. So you can actually decide that which GPU to use. So GPU ID is equal to, if I had put 1, then it would have run on the first GPU. I put 0, so if I have put 1, then it will run on second GPU. So since I have put 0, so it will run on first GPU. So you can decide which GPU to run. These are the scale factors. This is just mostly constant. It's only for pre-processing factors. And these are the model files, right? You decide which model to use. So for primary classifier, this cafe model, this model is being used. And accordingly, you need to for this cafe model, you need to provide this prototext file. So you, for whichever model you decide, accordingly, you need to provide this model file, label path, because whatever model you are giving, accordingly, you need to provide which label, accordingly, label path also you need to provide. Similarly, there are multiple number of classes, four. So many properties you can define it through that. So and if I did like output, so I will not go much in detail. So I mean, otherwise you'll get confused. But it's very simple to understand. I mean, this is the output layer, you are defining it here. But so like depending on the model, but it's as simple as it. So similarly, let's go to secondary classifier. Secondary classifier also you can decide, okay, which GPU to run on. And you can tell secondary classifier that it has to run on the output of first GPU, the first classifier, right? Because secondary classifier is cascading. So the first classifier, let's say how I can do that? So operate on the GIID is equal to 1, correct? Because so what I'm saying here is that you run on the output of the first classifier, right? So that's how we chain it together. Similarly, we do it here, correct? So that's it. So here also operate on GIID 1. So what I'm saying is that on the first classifier output, on the first classifier, it has to run, not on the second classifier. So that's how you chain. That's how this is also running on the first classifier itself. So if it had to run on the second classifier, then I'll just put it as a 2. So that's how I mentioned that how easy it is to change, all this configuration. Now you imagine that you have to do all these things in Python, PyTorch, how difficult it will be. I mean, it will be cumbersome, and that too you have to do in, in production environment. Here you have a model ready, and you can just you just make sure that you have a model, and you just put the model in the right path, and you can do all this setting here easily, and you can deploy your model. And all this model path and label, all these things you can provide it. Okay. Yeah. So in this one, we just ran till here. Okay. Element we created. Now we'll just set the property, right? So we'll set the property that we'll just provide the source location, input file name, what is the input file name, which file I'm processing. And also just for batching purpose, I am putting this width height for streamux so that it could do the batching. And these are the classifier properties for classifier that I'm putting. And these are the tracker properties. You can ignore it as of now. I mean, just by default property so that tracker is able to track it. Right? So now once I have defined the element, now I need to chain it together, because after source parser, after source, once I have the source, I need to parse that as 264, or if it have been MP4, I have to parse it. After parsing, I need to decode it. After decoding, the batching has to be done. After batching, primary classification. After primary classification, tracking. After tracking, secondary classification, and then series of classification or classification or detection. When I'm saying classification, I'm using it very generic, so don't stick it to be classification or detection. Okay. And then you do video conversion, then we enrich. So basically what I'm doing here is that I'm sticking just a stitching pipeline together like this, right? So that's how I'm adding into the pipeline and this linking it. So that's how I'm able to just adding into the and then linking it, that which comes first, which comes next. So this is the code to do it. I mean, you just source pad, sync pad, you link it, and you just link from primary classification to tracker to secondary to secondary. So that's how, I mean, you link all this thing, and then your pipeline will be ready, right? And then that's how you start the loop, and you start the pipeline, and and when I was mentioning about the buffer pad. So buffer pad, basically, if you want to see that what data is coming in, all that, what things are coming, then you can probe. You can probe that frame, and you can see the value. So for example, I have put the buffer. I'll just in this one, and I'm just trying to see. I'm displaying in my video. I'll show you an example. I'm displaying in the video that how many objects are there, vehicle count, person count, right? All those things I'm printing. So I'll show you in the code also. So yeah, So so this is how we do in the, actually what I'm doing here is that in this example, so I'm just accessing this frame data. Right? I'm just accessing this frame data, and from that frame data, I'm all getting that all this relevant information. That is very easy to get that information. Just display acquiring. These are the APIs, DeepStream APIs. You can go on that if you search DeepStream SDK. So these are all functions you will get. So that's how how to get from batch, how to get this function. You can just all this information. And that's how on the video also you can write this information, draw the bounding boxes. So now this should be fairly easy. So this is just a function. Okay. And I'll show you one. Okay. So now these are, and here I'm just running this pad. So I'm just adding this probe at this point. Right? So let me run this pipeline now. So once I'm running this pipeline, so see, starting this pipeline. So I'm starting pipeline. I'll, so we can see it will start printing after some time. So now it's initializing, and so can you see this? It's doing something. Frame number 0, number of detected person, something count, right? It's just these many frames it has detected. Like I mean, just finish the processing so fast, quickly it has done. See, so you see that. So in 24 seconds, 1500 frames, it just finished it because it ran on GPU. It just finished it because on that machine it just ran and it's done. So, and what is the output looks like? I'll just show you. So whatever the output was generated, I'll just convert into the video and show you how does it look like. It's converting. So it's just counting in each frame, basically number of objects, how many vehicles are there. And so this information was I was printing through this one, this probe function. You can see that, right? Number of object, person. That's how I was printing it, correct? So now let's see. So this one, okay, display. Okay. So see if my screen is visible. So can you see this? Okay, so on this, see, you can see. So I'll just pause it somewhere. See, you can see that what is happening here. See, it's detecting person, right? Person is saying person, 85 person, 18 counting person also, correct? It's, see, since I have used 4 classifiers, so detecting car, first detecting which vehicle it is, car. Secondly, detecting car color, right? S1, secondary classifier. Then it's saying which brand it is, Nissan, correct? Then it's saying type of vehicle, right? It's SUV, right? So that's how. So it's just see, so fast it's happening. So since it ran on GPU and so it's real time it's happening. So it's, imagine that on your you have deployed this on your traffic camera, right? And you are getting all this information and all this inferencing happening live. So whichever places it's able to do confidently with higher confidence, it's able to detect car color, car type also, and which vehicle it is. See these cars, silver SUV. See car 970 Volkswagen. Okay, so I mean, see this car, since it just found the car, it could not make out the which brand it is, because even we cannot make out. Right? As a human, we cannot make out. Then it's very difficult to make out here. So you can see this person, and it's tracking also. This is same person. So tracking. This is the advantage. So this person, it will not double count because the same person is going here, right? So that's the advantage. So that was it is. So I just wanted to highlight that. See, this simple it is to do it. So actually, if you just imagine that, just model building is one part, and in this example, you can see that this whole part is video acquiring and then processing this video, and whatever output was there, we need to just do this inferencing, and we need to. So when I was talking about this metadata, all these bounding boxes and this car, white, all these things, the information car make is just nothing but a metadata, and that metadata was found by NVInfer plugin, and that NVInfer plugin appended that metadata into the video stream. So here it is happening when I was talking about this page, right? So now this page start here. Yeah, so when I was talking about this metadata, NV12 metadata, so this metadata is nothing but those informations which actually is found by classifier. So that has been actually added here, and you can see that. So similarly, whichever model you, here I just taken the 4 model, and that's how I've done it. So you can pick whichever model and you can do it. Right? So that was from my side, and if you have any question, you can ask me. And if you have any further question, you can actually write me also at this email ID. I'll just write to everyone. If you have any further question, you can just write me over email ID, or you can just connect me with here also, if you just wish. And then that's the thing. And NGC you can try and explore. NGC, I'll just give you link here and try and explore. Okay, so